And we're going to do some multiplying problems because remember we do this so that we can see what factoring is. Factoring is the reverse of multiplying. And then we'll just practice doing these. You could check these with doing FOIL, and then we will talk about how to tell what type of factoring to do. So anyways, let's do a couple FOIL problems just to get going here. So we'll do this in our heads. We'll say x times x, that's x squared, nothing unusual there. These two multiply to -2. These two multiply to +2, and that adds to 0. So I'm just not going to write anything down. If you have parentheses where one is the same as the other, except one's a plus, one's a minus, the name of that is conjugates. You don't have to memorize the name. Those are called conjugates. And if you do have conjugates, the outsides and insides always add to 0. And then these two multiply to -4. Okay? We have to learn today how to go from this to this. And it might seem easy to you. Maybe you feel like you already understand how to do that. But let's do one more of these. So if I multiply these two things, I get a squared. These and these are going to be opposites. 6a and -6a. I'm not going to even bother writing them down. And then I multiply these, I get -36. So what you're supposed to notice here is a couple things. Do you notice how we ended up with minuses on both of them? They're always minuses. Okay. That's why it says difference. Difference is the word for subtraction. Okay. So when they say difference, they're talking about subtraction. These always have subtractions in them. If you look at these problems, see how they're all subtraction? Okay. They've got to be subtraction. Difference. And when they say squares, what are they talking about? Anybody have any idea why they're talking about squares? Like the difference between squares. I'm not drawing shapes. What do you think?
Perfect square.
These are perfect squares, exactly. So perfect square numbers like 4 and 36 and 25 and 9. And I'm telling you right now that if you have a variable squared, that's a perfect square too. So any even power is a perfect square. So x squared or x to the 4th or x to the 6th. Usually it's squared, but those are perfect squares. All right. See if you can do this without me saying anything. See if you can find the two things that if you did FOIL would land you with x squared minus 49. And you can actually do FOIL and check it. There's two ways to think about this. And I'm going to explain you both ways. Now we're just trying to understand both ways. When you do the problems, you don't have to actually do both ways, but if you can understand both ways, it makes it easier. So there's two ways to think about this. One way is to say, okay, I need to have a perfect square. Any even powers for a square. It's got to be minus, because difference means minus. And it's got to be another perfect square, 49 is per square. And then I do the square root of this one, x and x. I do the square root of 49, 7 and 7, and then one of each sign. So one's a plus, one's a minus. It doesn't matter which one's which. Everybody follow what I did there? Okay, I'm going to tell you a completely different way to do this one. I don't think that this way is better. I just want you to hear this so you know it's the same as what we learned. You could think of it this way too. You could say, I need numbers that multiply to -49. And you know how there's no term in the middle here? There's no x. So they have to add to 0 because there's no x in there. So I need numbers that multiply to -49 and add to 0. These two numbers multiply to -49, and if you added them, you would get 0. So that's another way to think about this. I probably wouldn't do it that way, but it works. Okay, so then this one is the rule in symbols. If you have something squared minus something squared, you would do the square root of this thing, put it down, do the square root of this thing, which I'd write y and y, make one a plus, one a minus. And so that's the rule in symbols, where that y and x could be any terms. So, you can look at these and maybe you know how to do 3, and you maybe not too sure about how to do 5 and 6, but we're going to go a little bit fast because these problems don't take that long. You don't have to do guess and check. You know, if I did guess and check, it would work, but it's just not necessary because these two numbers have to be the same. So I literally do the square root of this number, and you can use a calculator if you need to, but you get 5 and 5. And then I'm going to do minus and plus on this one. The order of those doesn't make a difference. Do 4 on your own. Anybody have any questions about what's happening here? If you're unsure about anything, use FOIL to check it. Those two things have to multiply to x squared. The two numbers here have to multiply to 100, and they have to be the same. So it can't be 2 and 50 or 4 and 25 or any other numbers that multiply to 100. It's got to be 10 and 10. And then one of them's plus, one of them's minus. The order doesn't make a difference. Anybody think they could do number 5? 5 is a little different because there's a number in front here. All right, Kay, you want to try this one?
Is it 2x plus 3 in the first line and then 2x minus 3 in the second line?
Yep. So you do the square root of the number 4, which is 2 and 2. It's got to be 2 and 2. It can't be 4 and 1. So you do the square root of 4, you get 2 and 2. You do the square root of x squared, you get x and x. So 2x and 2x. They have to be the same. They have to multiply to 4x squared. And you do the square root of 9, which is 3. So 3 and 3. Try, now that Kay did 5, you should be able to do 6. And if you're ever unsure about your answer, just multiply it out. Do FOIL. I know you know how to do FOIL, so you can just do all FOIL, and it should work out to be that answer. And then somebody might say, well, what if that number wasn't a 9? What if that number was an 8? Then you couldn't do this. What if that was a plus? Can't do this. Okay, it's got to be where these numbers are perfect squares. If that 25 was a 26, you couldn't do this. If that was instead of a power of 2, it was a power of 3, you can't do this. Okay, it's got to be in that pattern, difference of squares. They come from multiplying out something like this, and that should be your answer there. Square root of 9, 3 and 3. Square root of 5, 5 and 5. Here it says circle the problems that can be factored using difference of 2 squares. I wrote a bunch here. It's got to be perfect square, something squared, minus something squared. Okay, and I'll just say them, and you just tell me whether you think yes or no on them. We're not going to actually factor them. What do you think about A, yes or no? Yeah, that one you can factor using perfect difference of squares. It's x squared minus 3 squared. So that one's a yes. What about B? No, it's because of the plus. If it's a plus, it's not difference of squares. The word difference means subtraction. Difference of squares means perfect square minus perfect square. This is a perfect square, that's a perfect square, but it's not minus. Okay, what about C? That one's a yes. Those are all perfect squares. What about D? Everything's yes. When somebody said no? It's a no. This is a perfect square. This is a perfect square. But this x, what power is this x? 1. That's not an even number. That's a no because of that x. That one's a GCF problem. I could take an x out of both terms. That one's a no. The x's have to have even powers on them. So that one's a no. What about E? No. Is 24 a perfect square? No, it's not. And if you're not sure, you could just take out your calculator, do square root of 24. If you get a decimal, it's not a perfect square. All right. Try to guess on F. What do you think? Yes or no? Yeah. You think it is? Is 289 a perfect square? Yeah. What is it? What's the square root of 289? It is. Okay. So what you should do, I was just making sure people actually tried it. 289, most people wouldn't know. So you take out your calculator and say, I wonder if 289 is first square. You get 17. Okay? And then 1 is the first square too. Now, you don't really have to do this one, but let's write the answer down just so you can see it. It would be like this. Okay? Square root of 289 is 17. So it would be 17 and 17. P is raised to an even power, so you got P and P. And then 1 is the perfect square. Some people forget about 1. 1's the perfect square. And so that one is difference of squares. Okay. I wrote another problem. I wrote a couple multiple choice ones here to practice multiple choice. Like I said, in the final, there's a lot of multiple choice. So it's good to practice that once in a while. I think 8 and 9 should take 30 seconds total to do both of them. Why don't you take a second, try to answer those. On the test, they're not going to be, put into groups where like, these are all GCF problems. These are all difference of squares problems. These are all trinomials. You'll have to know what to do. So like if this is on the final, it wouldn't say factor using difference of two squares. It would say, factor this or which is equivalent. There's two ways to do this. You could factor this out, which is the easier way, or you could go through all of these and multiply them out until you get the one that works. But it's much easier if you know the factorization. It'll be much faster if you could just factor it. What's the answer to 9? Just yell it out. A. It should be A. Because you got to have one of each, a minus and a plus. So you can see how similar they are to each other, right? And then, I don't know if you noticed this, but C and D mean the same thing. If you have two things that mean the same thing, it's probably not the answer. Some people will ask me on the final, like, which of these should I put? It's kind of hard to answer that question, like, if they're both wrong. So I can't really answer that. But, hopefully people know what they're doing. Okay, so these are all mixed together. This is going to be a challenge for people. You could just go through and hunt for the difference of squares problems, but I want to do them in order, and I'll try not to go too slow, and I will give you advice as we go. But the difference of squares problems, we talk about how to identify them, and if there's 3 terms, it's definitely not difference of squares. It's something else, okay? All right, so look for them in this order, okay? First, look for GCF. If it's a GCF problem, that is what you do. Don't spend too much time thinking about it. If you could do GCF, do GCF. Then look for difference of 2 squares. Sometimes they call it difference of squares. They don't say 2 squares. It's the same thing. And then there's 2 types of trinomials. And we'll talk about them as we see them. But then you factor it like a trinomial. And like I said, there's 2 types, and we'll talk about them. Okay, so on number 11, can you do GCF? Yes or no? Yell it out. Yes. See, what happens is sometimes people will look at 11, and before they even think, they're like, okay, it says factor, bop, 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 and then they start thinking after they write that. If you write these 2 parentheses down like this before you do it, there's a very little chance that you're going to recover from that. Don't automatically write down 2 parentheses. Try to ingrain this in your mind. Look for GCF. If there's a GCF, you don't put 2 parentheses. 2 comes out of both these numbers, and they both have an X. There's only 1 set of parentheses on a GCF problem. Then you're going to divide these both by 2x. You divide by 2, that's 3, take an x away. Divide by 2, that's 4, take an x away. If you're not sure if it's right, do distributive property. It should distribute back to the original. That's a GCF one, okay? 11 can't be a GCF. And let me tell you how it's really easy to tell. Sorry, 12 is definitely not a GCF problem. And let me show you tell. If you have an x in two terms and not in the other, that means you can't take an x out of all of them, right? They all don't have an x. And if this one doesn't have any number besides 1, you wouldn't do a GCF of 1. Let me just show you what would happen if you thought it was a GCF of 1. And you said, okay, well, I could take a 1 out of this. You would be like, okay, take a 1 out. If you take a 1 out of something, you would end up with the same thing, but with a 1 in front. So you never do a GCF of 1. So if it doesn't have a number besides 1, it can't be a GCF. Or everything doesn't have an x. Either everything has to have a variable or everything has to have a number. This is the type of problem that's a trinomial. It's the easier type. You know these are x and x. You don't have to guess and check. In a way, you are kind of guessing and checking. You're just not really writing a whole lot. You're finding numbers that multiply to negative 18. Okay, so you are guessing those in your head. But in your head, you can find ones that add to 7. If you like this thing that we did on the tougher trinomials, you could do that on these. So if you like this thing where you write this down, go for it. You're going to need one of each sign. They have to multiply to a negative 18. So one of them has to be positive, one of them has to be negative. The numbers end up being 9 and 2. You don't have to write this down. Okay, and the reason you don't have to write this is because, look, the two numbers here are just these two numbers. So that's why in these problems, I could just see if they add to, I can just make sure they add to 7. If you like that method where we do the two multiplications and add, no one's stopping you from doing that. It's just not necessary. It is necessary on a problem like 13. What's wrong with me? Because that 3 in front. Because that 3 in front, you are going to have to do guess and check. So let's just start from the beginning. Okay, it can't be GCF. This doesn't have an x, so it can't be an x. These three numbers, the only number that comes out of them is 1, so you don't do GCF. It can't be difference of 2 squares because it has 3 terms. Same thing with this one. It can't be difference of 2 squares because it has 3 terms. The thing we just learned today is a binomial type of factoring, and these are trinomials. So you guess numbers that multiply to 3. Not a lot of guesses there. It's got to be 3 and 1. You guess the signs as minus plus. You might need to change them. If you memorize the sign chart, it helps. If you accidentally put down minus and minus, you will be guessing and checking. It'll never work. So if you memorize the sign chart, you'll be saving yourself time because you won't accidentally put down the wrong signs and make the problem impossible. There's only 2 things to guess. Either it's 2 and 1 or it's 1 and 2. So you multiply these, add. Try to practice some of these problems on paper because if you're doing all notability and then, for the very first time, on the quiz or the test you're using paper, it might throw you off a little bit. Okay, is that the right combination? And there's nothing else to try, right? I tried 1 and 2. I tried 2 and 1. This came out to be 1x, and I wanted negative 1x. And what we said yesterday was, if you get the wrong number, switch the numbers. If you get the wrong sign, switch the signs. So I'm going to make this positive and negative. And this will make everything opposite. And it'll give you the negative 1x. So in those 3 problems, those are the things you learned previous to this notes. We learned GCF in the first notes of factoring. We learned trinomials without a number in front in the next notes. And we learned trinomials with a number in front in the notes after that. And then we learned greatest common factor. This problem is a greatest common factor problem. Okay, how do I know that? Well, first of all, it doesn't have a GCF. This has no number, this has no letter. Can't be a GCF. It can't be a trinomial because it's a binomial. And is it something squared minus something squared? Yes, it is. You can yell it out. What's the answer to this one? So I'm going to yell it out. Yeah, be careful about that. X plus 4x minus 4. It says you'll write 8, you know. Just be careful on those. All right, so I want you to take some time now and go ahead and just pick some problems. You know, you can jump around. Pick problems you know how to do and do as many of these as you can right now. I'm going to stop the video because the people at home can, you know, just do these on their own.